Welcome back, everyone. We live in a really exciting time where there are all kinds of advances in technology that make things, for those of us who like to do a bunch of things with guitars ourselves, a lot more accessible. One of those ways and one of those areas is in manufacturing. In particular, I'm talking about 3D printing. 3D printing allows us to make things with complex geometries without having to worry as much about how we might hold the work if we're going to do subtractive machining of it, or how exactly we would get tools into certain places. We can create these geometries that are really complex, and in addition to that, we can also take things that wouldn't normally be cost effective to make just one or two of, and we can make them for a price that's really quite attractive. For example, for one of the guitar pedals that I've been working on, it is a Monty Python theme, and so I decided to make this little knob that is the Holy Hand Grenade of Antioch. And it was super easy to print out. The hardest thing was actually designing it in CAD, which even then wasn't all that difficult. But one thing that I have found even more exciting than the 3D printing of plastics is the 3D printing of metal. With the ability to print metal, things like hardware parts for our guitars become super accessible even for a one-off. To give you an example, I found a bridge online from a Vox series of guitars that was discontinued some number of years ago, and I was really quite smitten by the design. It's really quite elegant, it has lots of curves, and it is not sold anywhere anymore. Like, all the parts places are out of it. Even finding a guitar that has it on it is not super easy. And so I spent a couple of hours modeling it in CAD, and I created a 3D printed prototype in plastic using my little 3D printer that I have here. And then after I was satisfied with it, I sent it off to be printed in metal. And the result is this bridge right here, which, as you can see, is, I mean, it's not the most complicated design in the world, but if you were to send that out to be machined by a traditional machinist, it would be a whole lot of hours on the machine, and it would probably cost you for a one-off something like a couple of $100 pretty easily, possibly even more. And so today I want to go through and talk about the 7 things that I found most important as I've been doing some of this 3D printing in metal, so that you guys can also be aware of them, so that you can try and make the decision of whether or not 3D printing your own guitar parts is worthwhile to you or not. So the first thing is going to be the cost. That's the one thing that everyone asks about. As far as the cost goes, it's based on a volumetric measurement, so how much actual material are you using, and it also seems like to some extent the complexity also comes into play, because I made a test design that was just a cylindrical knob, but I hollowed out these honeycomb chambers inside of it to reduce the amount of material that it used, so that it only used about a third the amount of the material, but the printing cost actually went up compared to just printing it like a solid cylinder. Okay, but compared to traditional machining, the cost is way cheaper. So I've got some parts here for examples. So this is my bridge design. I designed this bridge. It's inspired by the Baby Grand, but I designed it to actually go with one of my guitar designs because the curves actually worked better for it. And so this bridge, now the saddles and the screws and springs obviously were not printed, but the bridge itself came out to be about $40 before shipping, and this thing weighs probably 3 or 4 ounces. It's fairly significant in terms of the weight. However, I also went and priced it out at an online machining service, and for a single part they wanted somewhere on the order of $200 for a single piece. Once you got into the quantities of 25 or 50 or 100, the price started to come down, but I had to put in a quantity order of between 25 and 50 just to get it down to a per piece price that was the same as what I paid for that one bridge. Now, the other thing that goes along with that, however, is because the per piece price is really low and because there are no efficiencies in scale with 3D printing like there are with machining, you don't really see quantity discounts the way that you do with machining. Some services will actually have a higher initial price per piece and it will come down a little bit in quantity, but it's not nearly as drastic as it is with machining. With machining, if they get the CNC program all put together and everything, then machining one piece and machining 100 pieces is not significantly more difficult, and so you're paying a lower price per piece that way. I just to be clear, I am only talking about the service offered by JLC 3DP. That's the 3D printing branch of JLC PCB. There are other services that can, vary things a little bit in terms of materials offered and cost and, some of those kinds of options, but I'm only speaking to what I have experience with today. So with the cost to print these, another thing to keep in mind is that there is a minimum parts cost. So each part has a minimum price. For example, at JLC 3DP, the minimum part cost is $8. And that means that no matter how small you make your part, it's going to be at least $8. And that's to cover the fact that they're running a machine that starts at $100,000. It's probably significantly more than that. And that they're using, very expensive material, and that this printer is sucking up a ton of energy to create a laser pulse that is powerful enough to melt the metal together. So for example, my little dome knob here was $8, the minimum part cost, which I was fine with $8 for a custom knob, no big deal. But when I considered making a switch tip that matched this, I was a little more hesitant to spend $8 on a little tiny switch tip. I might still end up doing it just so that everything on the guitar goes together and matches well, but just keep that in mind, that you're not going to be able to print off a 3D print off a metal part that's going to be just $2 or $3 because it's really small. That's not going to happen. The second thing of note is actually the surface texture. So if you paid attention on this bridge here, you'll see that on the flat top surfaces, let's see if I can get that to focus up a little better. Maybe. On those flat top surfaces, you get a kind of a bumpy texture, and I'll put some pictures up that show it a little better. You get a bumpy texture on there just because of how the powder lies when it's getting melted by the laser to create that top surface of the part. And so if you're looking for parts that are perfectly smooth on top, then 3D printing in metal is not for you. If you have a way of sanding them after the fact, then you can go ahead and do that. But on some of these more complex geometries, I would not want to be sanding this. So for example, with these curves on this Vox style bridge, sanding that would take forever to get out because this is 316 stainless steel, and if you're not familiar with the stainless steel grades, 316 is a beast to work with. Okay, not only is it hard and tough, but it also work hardens, which means as you sand it or grind it, it gets harder the more you work it. So trying to sand out all of those imperfections would be a pretty monumental task, and I wouldn't want to do it. So if the surface texture is not your thing, then I don't really recommend it, okay? The next thing is when dealing with thin parts. So the way that these parts are made is that there is a bed of powdered metal and a build plate gets put on there, and they laser the top layer of the metal to melt the metal powder together so it creates a solid layer of metal. And it goes one layer at a time, building and building and building like that. And so as it does that, if you have parts that are really thin or that have really like narrow profiles, you can actually get some warping in your parts simply because you've got all this heat that's being put into the system, and the only thing that is holding your metal together structurally is the melted material. There are no, they don't usually do supports because all of the unmelted powder acts as a support for the melted powder. So for example, I printed a pair of humbucker rings so that I had a matching set of hardware for my bridge. And they've got the surface texture on there still, but the thing to note is that they're not perfectly flat, even though they were designed perfectly flat. So if I were to take these two and put opposing sides together like this, you can see that there is a gap in between those two parts, meaning that they both are bowing in this direction. Now, for the sake of humbucker rings, it's not that big of a deal. The force of the screws would probably flatten it out, and if not, because I haven't tried yet, you can just put this over like a large diameter pipe and bend it a little bit to flat. So for these things, it's not that big of a deal. But be aware that if you're trying to design something that is really thin and you want it to be perfectly flat, then you're probably going to be better off looking at laser cut parts as opposed to 3D printed parts. Another thing that's important to note is the surface finish on these. Even though it is 316 stainless steel, the way it comes from the factory is not very impressive looking. So this right here is a single base bridge that I designed. It's a Dingwall style bridge, and this is how it comes from the factory, which is this very kind of dull gray, and I'll put up some pictures to show it a little bit better. And if we compare that to our humbucker ring here, let's see if we can get our camera to focus not on my face. It's not working very well. Let's see, can I go like this? So the surface finish is not as nice. It's kind of a dark dull gray, and so the way that I polish up my parts is using a wire wheel on a bench grinder. It's just a standard wire wheel, and it brightens it up a little bit. It's not going to make it super shiny. I did work through a series of different deburring wheels and then polishing grits on one part, and there was no real noticeable difference between actually polishing it with a polishing compound and just hitting it with the wire wheel. So my recommendation is that if you have to have parts that are really super shiny, then either budget in that you're going to get these plated after you wire wheel them, or just look at having a part machined and then plated in your plating of choice. Another consideration is going to be the weight. Now keep in mind that I'm only talking about what I have experience with, which is 316 stainless steel, and this bridge has a little bit of mass to it. It is heavier than, say, like a Hipshot hardtail bridge, which is made out of brass with stainless steel saddles, because there's more metal mass here, even though the densities of steel and brass are similar. So if you're going to be really conscious about the weight of your hardware, then you might want to look at one of the other services that offer like a 3D printed aluminum. I don't have any experience with it, but from looking at pictures online and everything, it looks like the aluminum might not have quite as nice of a surface finish. And if you're going to wire wheel aluminum, you don't want to hit it with a steel wire wheel, because the steel is going to gall the aluminum. You'll be better off using something like brass, a brass wire wheel, for example. So weight is certainly something to take into account. I've got a set of 3 knobs that I made. So I designed this knob that has, this helix pattern in here, and it's a dome knob. And, these knobs are heavier than anything that I've put on a guitar to date, really. But, they're probably about the same as a brass knob. I just typically will use wood knobs, or I'll use aluminum knobs that I make on my metal lathe. But I decided I wanted to try printing out a knob like this so that I could get this, this helix pattern that I wouldn't be able to easily machine in on the machines that I have here. Another thing to keep in mind is that this stainless steel, because it work hardens and because it's a very hard steel in general, is that if you're going to do anything with threaded holes, you want to make sure that those holes, that the pilot holes, are oversized a little bit compared to what you would normally use for a standard aluminum or brass or even a mild steel. You can see on this knob here that I have a set screw hole there and I have a set screw hole there. That's because this was the hole as it came from being printed, and it was undersized, probably about 10 thousandths of an inch is all, compared to what I ended up using, and a tap broke off in there. And you know, when you break a tap, it can be a real pain to get it out. In fact, if you don't have a milling machine with carbide tooling or some sort of like an electro discharge machining machine, you're not getting that tap out of there. I mean, it's in there for good. So do yourself a favor and you know, make sure that your pilot holes for threaded holes are a little bit bigger. You can actually design them in the same size as you normally would. Just drill them out just a little bit bigger before you tap them, so that you don't end up like me with broken taps inside of otherwise good parts. The final thing to consider is that because you are printing the steel by aiming a super high powered laser at this metal powder and melting it together, really thin profiles or places where you have these really sharp kind of acute angles are really prone to chipping out during the printing process. There simply isn't enough structural integrity to hold some really sharp edges. You can see on the string through holes on the back of this bridge here that things get pretty thin along these edges, especially up here where I've got an angled profile meeting this hole at less than a 90-degree angle. Now, fortunately, on this particular one, nothing bad happened. Okay, everything held up just fine. But it is something that as you're designing a part that you think you may get 3D printed, just keep that in mind so that you don't accidentally create a geometry that is going to result in ruined parts. Now, JLC 3DP is actually really good about doing doing checks on anything that you send in to be 3D printed with them, and they will highlight any potential printing risks. Sometimes those risks are worth it. Other times they aren't. So an example of where they highlighted a risk to me and I went ahead with it is on this base bridge here. So they don't like printing really thin wall profiles here, and there's a thin wall on the edge of on the right here on the edge of this part. But because I had machined one of these in aluminum before, I wanted to make sure that I had kind of that nice thin wall there because it worked for the geometry of the part and for the look that I was going for. So just be aware that as you design parts and you submit designs to them, there will be times where they come back and say, is the risk acceptable for this? And there have actually been some times where I've sent something in to be printed and they simply said, nope, sorry, can't do it. And so, you know, take some time to read through their printing guides. They're not necessarily set in stone, but they're good general guidelines. And after you've sent in a few parts to be printed, you kind of get a feel for the types of things that you can get away with versus the types of things that might be a little dangerous, if you will. So I hope you found all of that information useful. It's really cool to see a design that you've put up on CAD become, you know, a metal part in your hand, especially if it's something that is, you know, your own design that, you know, you might not have the facilities for making on your own. When I first started getting into making my own hardware, it was using a jigsaw with a metal cutting blade, a drill press, and a belt sander. That's how I made several individual bridges for a multi-scale guitar the first time I made any hardware. I now have, you know, a metal lathe and a milling machine out in my shop but still there are things that even with those capabilities, either I don't have the time to really go through it, or it's just easier to, you know, spend the $30 or $40 to get it printed out, as opposed to going through and you know, spending the couple of hours at the machine machining it out. So you know, I really highly recommend it. It is a lot of fun, and it can really make your guitar a custom creation. Even if it's like an off the shelf guitar, you can jazz it up in a way that is entirely your own. You know, truss rod covers, pick guards. I mean, the sky's the limit. Just, you know, use your imagination and have fun with it. And I hope that you got something of value out of this. If you haven't subscribed, I recommend you do so so that you're notified when the next video comes along. But until then, thanks for watching and take care.